Okay, this is a section on factors. We are covering 2.3 right now. Here's a few definitions for you. You want to make sure that you pause the video, write these down if I'm going too fast. But factors are numbers multiplied together to give a product, are called factors. 2 times 5 should be 10, I apologize. 2 times 5 is 10, so both 2 and 5 are factors of 10. The numbers 1 and 10 are also factors of 10 because 1 times 10 is 10. So here's how you list out factors. When you're asked to list the factors, you separate them by commas. So 1, 2, 5, 10 are the factors of 10. The other vocabulary term is a prime number. It's a whole number that has exactly 2 different factors, itself and 1. So here's an example. 1 times 3 is the only way that we get 3 when we multiply whole numbers together. That makes 3 prime. So here are the other list of prime numbers that are under 50. 2, 3, 5, 7, 11, 13, 17, 19, 23, 29, 31, 37, 41, and 47. These guys are not friendly. They only have 1 times itself to be able to multiply to give you one of the numbers that are listed. So that means that they are not, they don't have any other factors besides 1 and itself. They're the number that they are. So 23 is 1 times 23. Those are the only 2 factors of 23. All right, there's 2 more rules here, or definitions. A composite number is a number that is not prime. So any number that you can think of that was not on that prime list, remember these are only prime numbers under 50, so there's a lot of other ones. But any number that is not a prime number is a composite number. But there's a little tip here, and it says that the numbers 0 and 1 are not prime, and they are also not composite. They're kind of a standalone by themselves. Prime factorization is factoring like we've done on the very beginning where we found the factors of 10. But instead of it being just factors like that, it means that all of the factors that you would find for your answer would have to be prime numbers. Okay, and I'll show you how to do that in just a minute, but there's your definition. And before we get started too much into this, you may want to double check the rules that we talked about in the Unit 1.5 lecture notes. They're all written out there. That's why I point you to the notes instead of the lecture video. It may make sense for you to be able to print them off and use them for this next section. All right, so let's practice a few factors and then we'll move on to the prime factorization. So our first example would be 12. I want to write all the factors of 12. How do I do that? Well, I start by finding what numbers multiply together to give me 12. And I start with 1. 1 times 12 gave me 12. 2 times 6 gave me 12. 3 times 4 gave me 12. And here, notice what I'm doing. I'm starting with 1 and I'm working my way through the numbers. And here I would write 4, except for I don't need to because I already have that answer. That means I've already made my way through the cycle of numbers and I've ran out of numbers now. So with that being said, when I list these out, the number answers are 1, 2, 3, 4, 6, and 12. These are the factors of 12. These are not prime factors like we talked about in this rule up here, right? Because we know that 4 and 6 and 12 are not prime numbers because 2 times 2 is 4, 3 times 2 is 6, and there's several factors of 12 that we talked about right here. So this is not prime factorization. This is just listing the factors of a number that they ask us to do. Let's try another one. Factors of 60. So we're going to go again starting with 1. So 1 times 60 is how I got 60. And 2 times what? Well, 2 times 30 gave me 60. 3 times what? Is there a number that falls here? Right? 3 times 20 gave me 60. What about 4? I don't find, is there a 4? Is it 15, I believe, right? Because 15 and 15 is 30. And so another 15 and another 15 would also be 30. So this would be 60. So yes, this would be 15. What about 5 times 12? Yes. 6 times 10? Yes. What about 7? 7 does not go evenly into it. What about 8? 8 does not go evenly into 60. What about 9? 9 also does not go evenly into it. I would say 10, but notice that 10 is already used right here. So that means that the list that you see right here is our full list. So our answer is going to be 1, 2, 3, 4, 5, 6, 10, 12, 15, 20, 30, and 60. Not the best handwriting, but you're understanding that we list them in order from smallest to greatest and separate them by commas. What are we doing? We found the factors of 60. All right, so to lead us into our prime factorization, let's work on this little example here. I've listed on the board 5 numbers. And of these 5 numbers, my question to you is which of the following are prime? So we go through and we look at these and we say, how did I get 2? 1 times 2, that's the only way. How did I get 5? 1 times 5. How did I get 11? 1 times 11. How did I get 15? I got 15 by 1 times 15. I got it by 3 times 5. Is there any other ways to get this? Okay. How did I get 27? 1 times 27 and 3 times 9. So the ones that only have itself times 1 are my prime numbers. The other ones over here are what? They're composite. Because there are more factors than just itself and 1. So in the next example or exercise, we are listing out all of the factors only using prime numbers in our final answer. So let's try this. Our first example is going to be 12. We are going to use prime factorization of 12. And a lot of people know these as the factor trees. So you're going to start at the top and you're going to branch it out. And you're going to write 2 numbers that multiply together to give you 12. So what 2 numbers? 2 times 6. So 2 times 6. Notice I put a dot between them to show that we're multiplying. Is 2 prime? Yes, because we said on the previous screen that the only way I can get 2 is 1 times 2. So when I have a prime number, I will circle it. Is 6 a prime number? No, because I can multiply and break this apart and find that 6 is 2 times 3. We already said that 2 is prime, so I'm going to circle this one because we're done. And what about the 3? Is the 3 prime? Yes, because the only way I got 3 was 3 times 1. And notice that all of my branches ran out here. There are no numbers that can be broken down further, okay? So what I have as an answer is 2 times 2 times 3. So let's check our work. 2 times 2 is 4, bring down the number I haven't used, and 4 times 3 gave me 12. This is the answer that matches what we started with. So I know that this is right. But here's the catch to this. Since there are 2 numbers that are identical, we will write the number that we see, and we see 1, 2 of them, and so we see 2 as the power. So my final answer is 2 squared times 3. Why times 3? Because here's that times 3. We need it to end up equaling 12 at the end. The exponents are hard for some people, so don't get discouraged. I'm going to do another one, and it'll help us out. All right, this example is going to start with 48. I'm going to branch it out. And I will tell you that I usually start with a small prime number. I want to make sure that I can have a prime number to stop and only one number to break down. So what am I saying? I know that 48 is even, and I know that 2 goes into an even number evenly, and in this case it goes 24 times. Notice that 2 is prime, and so I'm going to circle it and it stops right there. 24 is not prime, and it's going to break down again. Remember, I just told you that when I'm splitting things apart, I want one of the numbers to be prime and the other one to hopefully be prime too, but if not, then I'll break one number down as we move on. I found 2 to be prime again. And why did I use 2 and 12? Because notice that right here, 2 times 12 gave me 24, that number at the top of that little tree. So 12 is not prime, so we're going to break 12 down, and I end up with 2 times 6. Here's my other prime number, but 6 breaks down again because it's not prime, and it becomes 2 times 3. Well, 2 is prime and 3 is also prime. So I have no more branches that will continue on. And so what do I have? I have 2 times 2 times 2 times 2 times 3. These match, so I write what I see, and how many do I have? 1, 2, 3, 4 of them, and so there's the 4th power times 3. Exponents say what you have in the big number and how many times you have it being that exponent. So this is my final answer. Okay, we'll try one more. There are extra practice problems found in your notes, your lecture notes for this section. So if you want to practice some more to get a little bit better, that would be the place that you can practice those skills. I'm going to split this screen and I'm going to show you that as long as you keep breaking numbers down, it's okay that you do them in different ways. So let's say that my paper says that I start with 45 and I decided to use 3 and 15. 3 is prime, I break down 15, and I end up with 3 times 5. Those are both prime, and so I found 3 times 3 times 5, which is 3 squared times 5. Or what if I went the other way? What if I came up here and I split this to be 5 times what? 5 times 9. I know that 5 is prime. I'm going to split the 9 to be 3 times 3. And I find that these are both prime, and so I end up with 3 times 3 times 5, which again is 3 squared times 5. So it's okay that you choose a different factor as a starting point. See, these did not match across here, but these are both factors. 3 times 15 is a factor of 45, and 5 times 9 is a factor of 45. So as long as you're choosing correct factors to start, then you'll end up with the right answer as long as you break them down continuously until everything you are left with is prime.